Let's try to split something like this, 2x minus 1 over x minus 3 times x plus 5 into partial fractions. Call it example 1. Now notice that this is a proper fraction. So if you have a proper fraction, then you want to think of this as a sum of two proper fractions. And what about the denominators? Well, it looks like your fractions, component fractions, should have denominators of x minus 3 and x plus 5, because when you take the common denominator, you're going to get this. Now, what about the numerators? Well, if you start with a proper rational function, you can't have improper fractions here. So that means the degree of the numerator would have to be less than 1, which means it has to be just a constant. Same thing here, it's a constant. Now what we notice is we can simplify the right side. We take the common denominator, x minus 3 and x plus 5. You divide each of these into that and then multiply with the corresponding numerator. So you are going to have a times, when you divide this into that, you get x plus 5, plus now that numerator times, when you divide x plus 5 into that, you get x minus 3. Alright, notice the left and right sides. They have the same denominators, which means the numerators must be equal. So 2x plus 1 is equal to the numerator. Let's distribute that ax plus 5a, distribute a here and distribute b there, plus bx minus 3b. And we can combine the like terms. You can think of a and b as just numbers. We don't know what they are right now, and that's what we are trying to find. So a plus b, these two are the like terms, a plus b times x, and then these two are constant terms. So we can group them together, 5a minus 3b, and this happens to be equal to 2x plus 1. So this is a polynomial in x, and that's a polynomial in x. And when are two polynomials equal? Well, when their corresponding coefficients are equal. So I'm going to write a plus b equal to 2. So now I have a plus b equal to 2, and then this is the constant term on the right, that's the constant term on the left. 5a minus 3b is equal to 1. And you now have a system of two equations in two variables, and whatever method you feel most comfortable with, you can use that. I'm going to multiply the first equation by 3 so that I get positive 3b, and I have negative 3b down below. So when I add them, they cancel each other out. I can get rid of the b. So now it's 3a plus 5a, which is 8a, plus 3b minus 3b. They cancel each other out. And notice, don't forget to multiply the 3 with 2. So that's 6 and 1 is 7. So this is giving me a equal to 7 over 8. So this is my part of the solution. I still have to find b. I can go back and plug it into the first equation. A plus b equal to 2 gives me 7/8 plus b equal to 2. And I can subtract 7/8 from both sides. 2 minus 7/8 is 9/8. So this is what I'm getting. Now I can write down my partial fractions. So how do I write 2x minus 1 over x minus 3 x plus 5 as sum of partial fractions? A is 7 over 8. That's what I'm going to plug over there. 7 over 8 divided by x minus 3. And b is 9 over 8 divided by x plus 5. And why do we care to split this? Because if you have to integrate this, it's going to be hard. Whereas you can integrate these two pieces easily because you have just a linear function in the denominator. And that can be done using substitution method. So that's what you would do if you have your denominator as product of two linear factors. Now let's look at one example where the denominator is, so let's write down say 3x plus 5 and say the denominator now has a linear factor and also a quadratic factor, x squared plus say 7. Now if you are going to write this as partial fractions, you want to think of two fractions that have the denominators of x minus 1 and the denominator of x squared plus 7, because when you take the common denominator you should get this, which means each of the denominators is that. And now this is a proper fraction, which means each of these fractions must be proper. So I can take this to be a because the degree has to be smaller. But notice here the degree of the denominator is 2, and any proper fraction can have degree either 1 or 0. So I just can't say that it has to be b, but I'll say it's going to be something like bx plus c, because I want to take the general polynomial. Now, if it happens to be just a number, then when I solve for b, I would get 0. So now I'm going to combine or simplify the right side. I get x minus 1, x squared plus 7. And then I have a times x squared plus 7 plus the numerator is bx plus c this time, multiplied with x minus 1. And notice you want to take this polynomial in the numerator, equate it to this polynomial, and actually solve for three unknown constants a, b, and c. And let's skip that part. I just wanted to show how to set up, and the algebra can be done later on. There's one other situation though that we should discuss. What if you have say something like 5x minus 7 and you have say just one factor but it's repeated. Now this one, oh, and also say one other factor, so x plus 1. So how am I going to take my factors now? I got to take as a over x plus 1, and this one, x minus 3 quantity square, I could have gotten it from two separate fractions. I could take b over x minus 3, and then I can have a denominator of x minus 3 quantity square as well. Now, when you have this common denominator, you want to consider the general case. You may have, well, you're going to have one fraction which has x plus 1 as the denominator. But you may not just have this fraction, c over x minus 3 quantity square. You may also end up having a factor of x minus 3 quantity square, which is just b. Now notice, I could have taken here it to be cx plus d, but that again would be unnecessary. I could just take it to be c. And then we do the usual process. We take the common denominator and divide each of the denominators into the common denominator, multiply with the corresponding numerator, and get simultaneous equations in the unknown constants a, b, and c. Now, when we have to do some problems, we'll do, but I just wanted to show the setup of the problems for partial fractions.